Students, today class Electromagnetic Spectrum. So in the previous video, electromagnetic waves. Electromagnetic waves are transverse waves in nature. The activated charged particles which produces electromagnetic waves. The speed of electromagnetic waves 3 in 10 power plus 8 meter per second. So today class electromagnetic spectrum is very important to your examination point. Electromagnetic spectrum. The electromagnetic waves can be arranged according to the order of wavelength and frequency is called electromagnetic spectrum. The electromagnetic waves or electromagnetic radiations can be arranged according to the order of wavelength and frequency is called electromagnetic spectrum. Now, how to write the electromagnetic spectrum? Now, this is the spectrum. The electromagnetic spectrum consists of electromagnetic waves like gamma ray, X-ray, UV ray, ultraviolet rays, visible light, IR rays, infrared rays, microwaves, and radio waves. So now, students, you observe this diagram, this spectrum. So this order, this arrow mark indicate increasing frequency of electromagnetic waves. So now here this arrow mark indicate wavelength. So wavelength increase. So here lambda is a wavelength and mu is a frequency of electromagnetic waves. So one side the frequency increase, so wavelength decrease. So the electromagnetic spectrum consists of electromagnetic waves, gamma ray, X-ray, UV, visible, IR rays, infrared rays, microwaves and radio waves. Now here the middle part of the spectrum is visible light. Students, you observe this diagram here. The middle part of the spectrum is visible light. And one end here gamma ray, here X-ray, here UV rays, IR rays, microwaves and radio waves. So this spectrum is called electromagnetic spectrum. Electromagnetic spectrum, how they are arranged according to the order of wavelength and frequency is called a electromagnetic spectrum. So the middle part of the spectrum is a visible light. So now here UV rays, here X-rays, here gamma rays. So this is IR rays, infrared rays, microwaves and radio waves. So this is spectrum, electromagnetic spectrum. So after one column electromagnetic waves, scientist name and wavelength is very important. This column is very important to your 1 mark question. Write the wavelength of X-ray, write the wavelength range of gamma ray. So last column is very important in your examination point. Now students, here gamma ray. Who observed gamma ray? Willard. Willard first observed gamma ray. So gamma rays are emitted by radioactive source. So gamma rays are least wavelength and highest frequency. Gamma rays are least wavelength and highest frequency. So which electromagnetic waves are the least wavelength of electromagnetic waves? This is a 1 mark question. Gamma ray. So gamma ray is the least wavelength of electromagnetic waves. Who observed gamma ray? Willard. So Willard first observed gamma rays. What is the wavelength range of gamma ray? Less than 10 power minus 3 nanometer. This value is very important in your 1 mark question. Write the wavelength range of gamma ray. So less than 10 power minus 3 nanometer. So this point is very important. And one more question. Mention any 2 uses or applications of a gamma rays. So gamma rays are used to control the growth of cells. This is the first point. And second point, gamma rays are used to treatment in cancer. These are 2 important applications of a gamma rays. So gamma rays are electromagnetic waves. Who discovered or who observed? Willard. What is the wavelength range less than 10 power minus 3 nanometer. So this is the first electromagnetic wave, gamma ray. So after what? X-ray. So X-ray. Who observed X-ray? William Röntgen first observed X-ray. X-ray is high energy electromagnetic radiation. So what is the wavelength range of X-ray? 1 nanometer to 10 power minus 3 nanometer. So 2 years back in annual examination, this is a 1 mark question. Write the wavelength range of X-ray. So answer here 1 nanometer to 10 power minus 3 nanometer. So this question may be March 2018 examination, board examination. This is 1 mark question. The wavelength range of X-ray 1 nanometer to 10 power minus 3 nanometer. So who observed X-ray? William Röntgen first observed X-ray. X-ray is high energy electromagnetic radiation. The wavelength range 1 nanometer to 10 power minus 3 nanometer. What are the important applications of X-ray? So the first uses or applications of X-ray. X-rays are used to detect the fractures in bones. Detect fractures in bones medical field. And X-rays are used to crystal structure analysis. Neurochemistry crystal structure, single crystalline, polycrystalline, amorphous crystalline. So how they are identified crystal structure with the help of the X-ray. X-rays are used to crystal structure analysis and X-rays are used to detect fractures in bones. So second one is very important in the examination point. X-ray. Who observed? William Röntgen first observed. What is the wavelength range? 1 nanometer to 10 power minus 3 nanometer. It is very important your examination point, X-ray. So after, UV rays, ultraviolet rays. So sun is a natural source of ultraviolet rays. So who observed ultraviolet rays? John Ritter. John Ritter first observed UV, ultraviolet rays. So what is the wavelength range? 400 nanometer. 400 nanometer. 400 here. 400 nanometer to 1 nanometer. Students, the wavelength range of UV ray 400 nanometer to 1 nanometer. The last column is very important, wavelength range. So UV rays first observed John Ritter. The wavelength range 400 nanometer to 1 nanometer. This value is very important. What are the applications of UV rays? Ultraviolet rays are used to sterilization of air and water. Ultraviolet rays are used to chemical and mineral analysis is very important point. UV rays. So who invented UV rays? John Ritter. What is the wavelength range? 400 nanometer to 1 nanometer. This wavelength range of UV rays. Who observed? John Ritter. So the first three, gamma ray, X-ray, UV rays. So after students here, the middle part of the spectrum what? Visible light. So visible light. So this is who observed? Sir Isaac Newton. So visible light. So now your vision of light. What is the wavelength range? So 700 nanometer to 400 nanometer, or one more range, 4000 angstrom to 7000 angstrom. So students, visible light. Who observed? Sir Isaac Newton. The wavelength range of visible light 700 nanometer to 400 nanometer, or in angstrom 4000 angstrom to 7000 angstrom. This range is visible light. So our vision, the light range wavelength what? So 700 nanometer to 400 nanometer. Visible light helps us to see the surrounding things or surrounding objects. And visible light in our biology, photosynthesis requires for visible light. So visible light who observed are Sir Isaac Newton. What is the wavelength range? 700 nanometer to 400 nanometer is very important. This point, friends, the wavelength range of visible light. Or sometimes they mean angstrom, 4000 angstrom to 7000 angstrom the wavelength range. Visible light helps us to see the surroundings. So after what? IRS. The next after here, IRS what? Infrared rays. So who observed infrared rays? Herschel. So who observed or who invented infrared rays? Herschel. What is the wavelength range of IRS? 1 millimeter to 700 nanometer. 1 millimeter to 700 nanometer. This is the wavelength range of IRS. So IRS are used in applications. So chemical and molecular structure analysis. So their IRS are used to solar heat, solar cell, solar cooker, and remote switches for television. So various electronic devices are used for remote switches for IRS, infrared rays. So who observed Herschel? What is the wavelength? 1 millimeter to 700 nanometer. This is IRS or infrared rays. The last one, micro and radio waves. Micro and radio waves who observed Henry Childs. So already I told last class who experimentally confirmed electromagnetic waves. Henry Childs. Who predicted electromagnetic waves? Maxwell. Now students, here microwaves and radio waves observed as the scientist named Henry Childs. This is a one more question. Who observed micro and radio waves? So Henry Childs. What is the wavelength range of micro and radio waves? 0.1 meter to 1 millimeter. 0.1 meter to 1 millimeter. This is the wavelength range of micro and radio waves. So what are the uses of microwaves? Is a very important point in your examination, friends. Microwaves. So many times questions are arises in examination to board examination. Mention any one application of microwaves or mention any two applications of microwaves. Now friends, so what are the important applications or uses of microwaves? The first application, microwaves are used in micro ovens. Is very important point. Micro ovens. Friends, this is very important. You keep it in your mind. Micro ovens. It's a single word. You get 1 mark. Micro ovens. So after second uses, microwaves are used in radar system. Radar system for aircraft navigation. Radar system. And microwaves are used in communication system. Microwaves are used in communication system. So very important point. Microwaves are used in micro ovens. 1 point. And radar system is another point. Is very important applications for microwaves. And radio waves are used in radio and television communication. Radio waves are used in radio and television communication. So now this is electromagnetic spectrum. Friends, what is the electromagnetic spectrum? The electromagnetic waves can be arranged according to the order of wavelength and frequency is called a electromagnetic spectrum. The electromagnetic spectrum consists of gamma ray, X-ray, UV, visible light, IRS, microwaves, radio waves. These are electromagnetic waves. All electromagnetic waves have same speed, same velocity of light. C equal to 3 in 10 power plus 8 meter per second. All electromagnetic waves have same speed or same velocity. But different wavelength, different frequency. Wavelength and frequency is different for all electromagnetic waves, but speed is same. Now this spectrum. So this arrow mark indicate frequency increase from radio wave to up to gamma ray. So therefore gamma is the highest frequency. So here this order wavelength gamma ray to radio wave. So this order wavelength may be increased. Now your gamma ray is the least wavelength. So and this tabular column is very important. So one column electromagnetic waves, second column scientist name or discoveries, and last one wavelength range. So this value mentioned in your textbook, NCERT textbook. This tabular column is very important in your examination point, students. Students, a very important your examination point. Applications or uses of electromagnetic waves is very important your examination point, 1 mark and 2 mark questions. So first one, mention any two applications or uses of gamma rays. So the first one answer, gamma rays are used to control growth of cells. So students, here the first point, gamma rays are used to control growth of cells. Second point, gamma rays are used in treatment of cancer. The two are very important applications in gamma rays. So in your examination point, mention one or two applications of gamma rays. So now answer, gamma rays are used to control growth of cells. Gamma rays are used in treatment of cancer. And second one, X-ray. Mention any two applications or uses of X-ray. So first one, X-rays are used to detect the fractures in bones. X-rays are used to detect the fractures in bones. Second point, X-rays are used to crystal structure analysis. In crystal structure analysis in your chemistry, so amorphous crystalline, single crystalline, polycrystalline, amorphous crystalline, how they are identified with help of the X-ray spectrometer. So now X-ray are used to detect crystal structure analysis is very important for X-rays. So after mentioning two or one applications of UV rays, ultraviolet rays. So ultraviolet rays, UV rays, students here, UV rays. Ultraviolet rays are used in chemical and mineral analysis. Second point, ultraviolet rays are used to sterilize air and water in hospitals. Ultraviolet rays are used to sterilize air and water. Finally, ultraviolet rays are used in treatment of skin and certain bones. So very important applications. First, friends, mention two applications of infrared rays, IR rays. First uses, infrared rays are used to remote switches of electronic system such as television. So remote switches, electronic system, maybe television. Second point, IR rays are used in chemical and molecular structure analysis. UV rays are used in chemical and mineral analysis, but IR rays chemical and molecular structure analysis. And third point, IR rays are used in solar heater, solar cell. So various fields are used for IR rays. The 3 points are very important applications of IR and infrared rays. Next one, this one is very important. Students, microwaves is very important. So in previous exam, so many times questions may be arranged microwaves, maybe 1 mark or 2 mark question. Mention one or two applications or uses of microwaves. Now, microwaves are used in microwave ovens. It's very important. Microwaves are used in microwave ovens. This sentence is very important. Last one, microwave ovens. Next point, microwaves are used in radar system for aircraft navigation. Radar system is very important word. Radar system for aircraft navigation. And microwaves are used in long distance communication system. So now students, here three applications are there very important. Your examination point for microwaves, microwave ovens, first one. Second one, radar system for aircraft navigation, long distance communication system. Now the three are is very important, microwaves. So after last one, radio waves. Radio waves are used in radio and television communication system. Now students, so now the first part of textbook 6 units is completed. Now second part of textbook 4 units, ray optics, wave optics, so radiation, dual nature of radiation, atom physics, nuclear physics and radioactivity. Now the first part textbook 6 units is completed. In after numerical problems solved after reopen the college. So now you regularly watch the videos, the previous videos for 6 units. The first unit, electric charge and electric field. Second unit, electric potential and capacitor. Third unit, current electricity. The fourth unit, moving charge and magnetism. The fifth unit, magnetic materials and electromagnetic induction. The sixth unit, alternating current and electromagnetic waves. Now 6 units portions completed.